An important piece of landing equipment must be thrown to a ship which is moving at 45 centimeters per second before the ship can dock. This equipment is thrown at 15 meters per second at 60 degrees above the horizontal from the top of a tower at the edge of the water, 8.75 meters above the ship's deck. For this equipment to land at the front of the ship, at what distance from the dock should the ship be when the equipment is thrown? Ignore air resistance. Here, the ship is moving with a velocity of 45 centimeters per second. Okay. And then the dock, this is the dock. And an important equipment is to be thrown from here, this point, towards the ship. Okay. Now, this dock is at a height of 8.75 meters. And then the equipment is thrown with an initial velocity of 15 meters per second at an angle of 60 degrees with the horizontal. Okay, so now we have to calculate how much distance it should be. That means the equipment should, for the equipment should to land in front of the ship, what should be the distance? So for that, what we do is first we will write down the data. Here, this is the projectile motion problem. Actually, the equipment should fall 8.75 meters. So that is why I am putting the negative sign here. So here the y direction displacement is negative 8.75 meters. And it is traveling with a velocity of 15 meters per second, making an angle 60 degrees with the horizontal. So horizontal component velocity is 7.5 meters per second, because VA cos 60, no? Here VA is equal to 15 meters per second, and then angle is 60 degrees with the horizontal, and we have to take the horizontal component adjacent side, no, cos component. Therefore, it is traveling with the speed of 7.5 meters per second in the x direction. Okay. Now, in the y direction, what is the velocity? VIy is equal to VA sine 60. Therefore, 15 meters per second sine 60 is equal to 13 meters per second. Now, let us write down the displacement y direction, and from the equation, we have to find out the time. How much time it takes to drop a height of 8.75 meters. Okay, so for that I will take I will substitute the values in this equation. Delta y is equal to VA y t plus half at square, and here a is the acceleration due to gravity, that I am taking 9.8, and it is downward direction. That is why I am taking the negative sign. Okay, and then this also drop in the height, that is y direction displacement also negative. So negative 8.75 is equal to 13t plus half negative 9.8 t square. Okay, on solving for t, we get 3.21 seconds. Now we have to find out the distance. Here, what is happening? The equipment is traveling with a velocity of 7.5 meters per second for 3.21 seconds. And then the ship is also traveling. How much velocity? 45 centimeters per second. That means 0.45 meters per second. With that velocity, it is traveling towards the dock. Am I right? So both are traveling in the same direction. The equipment is in this direction, and then the ship is in the opposite direction. So we have to add these two velocities should be added and then multiplied with the time. So V relative is equal to this let it be V equipment, and this be V ship. Okay. So V equipment plus V ship gives the relative velocity, total velocity. Okay. And then this multiplied by time, and that gives the answer. Okay, because the distance is equal to Vt, no, d is equal to Vt. So here, this is the velocity. Now, otherwise what we can do is in 3.21 seconds, the equipment moves a distance of 24 meters. In the same time, 3.21 seconds, the boat moves a distance of 1.44 meters. Okay, so the total distance covered is 25.44 meters. Okay, this is how we can do the problem. Hope this helps. Thank you.